The new input system is a much cleaner and flexible way of gathering the player's input, but this flexibility comes at the cost of more complexity. The old input system worked like this. If I right click, create C# script, just call this player control. Double click to open it up. I'll just clear at the start. In the update method, we would have to say if input dot get key, and we could do key code dot d, and then we can say something. We would call a method like fire the gun or something, so I'll just put in quotes here, fire the gun. And let's say we also wanted to interact with an NPC. We could say if input dot get key and key code, let's say it was key code dot a, and then we would say interact with an NPC. Okay, now what if we wanted to do, jump? We would say if input dot get, and so on and so on and so on. So you get the point here, right? All of this repeatable code makes things quick to implement, but also not flexible at all. The problem arises when you want to change the buttons, change the behavior of the buttons, or most importantly, you run into a huge problem, which essentially breaks the game when the gameplay switches. For example, say you are building an FPS and have multiple gameplay situations like driving a car, swimming underwater, and moving on land. The arrow keys, or if you are on a controller, the gamepad, will be your primary way of moving around. But how can you tell which state you are in? How can you tell if the player is using a keyboard or a controller? After all, the player cannot alter any of these controls in the old input system. The most clear solution would be to check different bools every frame for every single different situation. But this would mean you would have a pile of code, a long list of nested if-else statements, all hard-coded, all dependent on the keys that are unchangeable, and not to mention the performance would take a massive hit having all this checked during the single update method. And this is not even accounting for all the other game objects you will have being constantly updated during each frame. By now you should be convinced that the old input system has these detrimental flaws. So the next question is, how do we use the new input system to fix these problems, and how are we supposed to implement it properly? The new input system fixes these game-breaking issues using input action assets. What is an input action asset? Simply put, an input action asset stores all of the action maps, and therefore all of the possible player controls. So to create an input action asset, we will click on Window, go to Package Manager, click on it, and instead of Packages that has in project, we will go to Unity Registry, and we will search for input system. As you can see, I have it downloaded here, and if yours says update, make sure you update it, but if it says install, then just click the install button. I already have it though, so I will continue. Now right click on the project tab, hover over create, and at the bottom of the drop down menu, we will select input actions. I'm going to rename this to player controls because it will handle the controls from the player. Now double click to open the input action asset, and we are greeted with this new window, which at first can seem intimidating if you have never seen this before, but I'm going to walk you through every feature and show you how to use it properly. In the top left corner, you can see the control schemes drop down. This is for separating different devices so the input does not get mixed. But this is not necessary to create, as we can just set up each input for each device wherever we want. So this is not needed. I'm not going to do this. To begin, we need an action map. So let's click on the plus button on the action map column. An action map is a container for the current state of the gameplay and will affect how the input from the player is interpreted. For example, if you wanted a basic container that held all the controls for when your player moved around and interacted with the world, you can create an input action asset named basic gameplay. But if you wanted an underwater section, you can create another input action map called underwater section. One for driving, one for flying, etc. The main thing I want you to remember is why we separate these different input action maps. Let's say we are on a computer. The arrow keys will move the player, but now the player is underwater. We now have the ability to switch the action maps, and the controls will now register differently because of the current enabled action map. So our up key will now be to swim to the top instead of jump. But then our controls for flying are different. No problem, we just switch the action map, and then we can go back to the basic gameplay when we switch back to it. The input action map tells your game what state the player is in and how it should treat the input it is receiving. So let's create a basic input action map. We'll call it Base Combat. Okay, I created an input action map. Now what? Now we can look over to the column on the right and see that it says Actions. This column is just what it says it is. It is the specific actions for what the player does. For example, moving, jumping, shooting, etc. So this column is the bridge that connects the physical input from the player and the actual data given to your game. For example, say the player moves using the arrow keys. We can create an action named move, which takes the different pressed arrow keys as input and gives our game the data where we can later code with this data to make the player move. Remember, the action is a bridge that connects the physical input the player puts in and spits out data based on that input. The next question: how do we set up certain inputs, and how do we determine what kind of data we receive? To create an action, we will click on the plus icon on the top right corner of the action column. By default, it has already created one for us. I'm just going to go ahead and delete this. Cut. And to create a new one, we could just click on this plus icon. For this first action, let's name it jump, because this action will handle the player's jump. As you can see, multiple things have occurred after creating just one action. For starters, underneath our created action, we have what is called a binding. The column to the far right now contains a new list of options. And we also have a plus icon for our newly created action. Let's break down what each one is and find out how each one works. Let's start with the binding. What is it? Remember when I said an action is the bridge from the physical input from the player to the data in the game? The binding is the start of that bridge. Bindings are the physical controls on a device that the player can use. Okay, but how do we set a specific input to the binding? If we look in the right column, we can see this path option under the binding dropdown. We can click on it and find whatever physical input we are looking for. And Unity makes this extremely easy by simply clicking the listen button and touching whatever key we wish to activate this action. This is where the new input system really begins to shine, as we can not only hook up keyboard controls, but we can also hook up mobile device controls and console controller controls for PlayStation and Xbox. This is why control schemes aren't really necessary, as we can manually hook up all the controls ourselves. Because we are in a jump action, I'm going to make this action trigger by the spacebar. Now under the binding dropdown, we have two more subsections: interactions and processors. Interactions change how the physical input can be activated. For example, what if we wanted the jump to occur by double tapping the spacebar or holding it down? The new input system offers this variety to customize the game to your needs. For me, simply pressing the spacebar works, so I will leave it blank. So what is the Processors tab? The Processors tab can modify the value received. For example, say you wanted a control to be inverted or clamped to a certain range. Then you could come in here and add a processor. I haven't used this yet, so I can't offer an in-depth analysis on every one, but I would recommend you check this out if you are interested in either inverting your controller values, having dead zones, which are primarily for controllers when you slightly push down on buttons or slightly move the joysticks. The dead zone means it will not activate until it is beyond the set value of pressure. If you're interested in tweaking your received physical input, you might want to experiment with this. So we have built the first part of our bridge with the physical input. We need to build the other side of the bridge, which requires data we received from the physical input. If we select our action, which is tabbed in green, we can see that the action properties panel is slightly changed. It will now have an option marked action type. This is where we decide what data we would like to gather from our physical input. In this case, the input comes from us when we hit the spacebar. So if we click on the action type, a drop-down menu appears with three different options: value, button, and pass-through. Let's start with button. This is a one-time action which sends data of the key on a keyboard or a button on a controller. In this case, the spacebar is being pressed. But if you alter the interactions as I showed you earlier, then the data will be received based on how you altered the interaction. More uses of button can be seen with firing a gun, whether you press or hold down the trigger button, or perhaps a melee where you press another button, and so on. Since button handles all of the singular action controls, such as jumping or shooting, we need controls that can handle and update the movement of the character. After all, the analog sticks on controllers are not buttons, and even if they were like a computer keyboard with the arrow keys, we would still need different data gathered because we need more information to move and rotate the player than just knowing that a button was pressed. This leads us into the next action types: value and pass-through. These both update continuously as the control changes, which is why these are both great for player movement. The only difference between these two options is that pass-through ignores the disambiguation process. This just means that when multiple devices are hooked up in the game, you can affect the player using a controller, a keyboard, or whatever other devices or controllers you have hooked up. But value only listens and follows one device's input per player, which is why I only use button and value. Pass-through requires a specific type of gameplay to be applicable, and when I play a game, I'm just sticking to one controller or one keyboard, so I haven't found a use case for pass-through yet. You can see that if we have value or pass-through selected, a new option appears, named control type. This is where we decide what information we want to gather from our value action type. For movement, we want vector coordinates to move our player, which can be found at the bottom. Some of these other options can be useful, but during my time using Unity's new input system, I have only used Vector 2, Vector 3, Quaternions, and Touch for mobile games. You can look into the other options if you want, but you can make almost any input mechanic with the main control types listed above. Since I'm making a jump mechanic first, I will leave it as a button. You can see the initial state checkbox under the drop-down menu as well. This simply checks whether your player is holding down a key or button before the game starts. I'm going to leave this unchecked. And finally, we have the plus icon on the action itself. If we click it, we are presented with a drop-down menu with the first option reading Add Binding. When clicked, this will add another way of executing the action. For example, under Jump, we have the spacebar as the physical input to trigger this action. What if we made a cross-platform game and wanted the Xbox controller's A button, or the PlayStation's X button to make the player jump? Or even if we wanted to have multiple ways to jump in the game on keyboard, let's say W, we can do that as well. So let's add these new bindings. For controllers, Unity makes it very easy to add. The lowest button on the controller out of the 4 main controls is called the button south, which works for PlayStation's X and Xbox's A button. The rest of the controls follow this pattern with button east, button west, and button north. Let's take a look at more of the drop-down options. If we click on it again, the next option is for positive and negative bindings. This is made for 2 buttons for seeing which direction the control is moving in. It will be negative moving in the minimum value direction and positive moving in the maximum value direction. If it is in the middle, you can decide which side wins. I haven't used this binding yet, as it is very specific to the type of gameplay you want. If you're going for a mechanic that has a 2-button pressing feature, maybe like balancing on a rope or a tall building, I can see this as being used, but for my game, it is not needed. The next options are to add bindings with 1 or 2 modifiers. If we select this, we can see a new binding has been created, along with a modifier. This feature is used for button combinations. Say you wanted to have a super punch that is activated when the user presses 2 buttons at the same time. Or maybe you have a sprint mechanic that shares a key with a walking mechanic. But this is where modifiers come into play. This feature is used when you want button combinations. And this is a great feature to have. One more thing I forgot to add. If you change your control type to a vector, then select the plus icon on the action, you can see an up, right, left, down composite is created. You can do this manually, but this is a nice shortcut for making the player movement action bindings. A composite is just a group of keys referencing the same action. If we select the composite holder, we can see a composite type and a mode. The composite type just holds the specific types of bindings like modifiers, as shown earlier, or vectors for movement. The mode defines what we should treat the input as, either as analog, digital normalized, or normalized. Digital normalized treats the input as buttons, so each direction is marked as 0 or 1. 1 for pressed and 0 for not pressed. Digital means the same thing, except the values are not normalized. For example, if you hold down the left and up key, the player will appear to be going faster because the inputted vector has a length greater than 1. It can be best represented as a box shape, while digital normalized can be represented as a circle shape. Digital normalization makes sure that your player moves at the same speed in all directions. The last option is analog, which marks your inputs as floats rather than ones and zeros. This is for controllers, as you can slightly move the analog stick without moving it fully to the maximum edge of the analog stick radius. So you can have a value of 0.5 on the right, which means you have moved it halfway to the right side of the maximum value, which is 1. With all of that out of the way, let's set up our jump action back to a button type. Save our input action asset, and start looking at how we can actually use this to affect our player in our game. So before we close this input action asset, another good way to do this is to just check on the autosave box so you don't have to save it every time. And now with the input action asset selected in the project tab, we can see another empty checkbox to generate a C# class for the player input. Let's go ahead and check that to make sure that all of our gameplay mechanics are created. If you have made it this far, congrats. All that is left is to show you how to actually implement it into your game. To start, let's find our player and add the component player input on him. Once added, this component has some available fields which are Actions, UI Input Module, Camera, and Behavior. Let's drag our input action asset we just created onto the action slot. Let's set our default map to the action map we just created, and the UI Input Module and Camera we can leave blank, as the UI Input Module is for interacting with UI elements like menus and pause screens, and the camera is only required for split screen setups when you need to determine which camera is attached to which player. But for this case, we will be simply moving the player, which does not involve interacting with UI or split screen multiplayer. The last option we can change is the behavior. This will determine how you choose to receive the actions the player inputs. We have 4 ways of getting notified that the player has inputted something. If we click on the behavior button, a drop-down menu appears, and we have the option to send messages, broadcast messages, invoke Unity events, or invoke C# events. First of all, none of these are wrong. They all have their own ways of implementation. I will go over all of them, show you the process of each implementation, and give you my opinion on them as well. To show you how it'll work, let's take the one control we have, a spacebar. When we hit the spacebar, we need a method to be called that takes the player and forces him into the air, therefore making him jump. Hopefully that's straightforward enough. So where do we put the method and how do we call it? To solve this, let's create a new C# script called player controller and drag it onto the player object. This is the script where we will call our action methods. Let's also add a rigid body 2D component to the player in order to have the player move in game using physics. To demonstrate how our first behavior works, which is send messages, let's take a look underneath the behavior option and we can see a list of actions. On device lost, on device regained, on controls changed, and our action right after. Except it is not named jump, but on jump. This is because send messages calls your jump method with the on word before your actual action name. For example, if our specific action if our specific action was called jumping, it would be called on jumping. If the action was called go higher, it would need to be named on go higher. The only other requirement for making this work is to make sure the script for calling the method, which we will create in the new script we just added, is attached to this game object. We already added the script component to this game object, so now we just need to call it. Let's double click to open up our new player controller script. To start, let's get a reference to our player controllers and our rigid body 2D. In order to use the new input system, let's also get access to its namespace. So to get actions to our player controllers, we can just say private player controls, which is our input action asset, and we can just call this player controls. We also need to get access to our rigid body 2D, so let's create a private rigid body 2D called RB. And then we can just assign this in the start method. Player controls is a new player controls. RB, we are going to get the component of the 2D rigid body. Now, let's create our jump method. Remember, we need to add the word on before we call our jump, and that gets called when our action is performed. So I will write private void on jump with curly braces. And in this method, we can write the logic. To see if our method is being called, let's first just write debug.log jump. Let's go back into Unity and play the game to see if our method gets called. And as you can see, every time I press the spacebar, our method gets called. Now let's actually make him jump. We will go back into our player controller script and add a force in the upward direction. So I will write rb.addForce vector2.up times whatever our jump force is going to be. I'll just say 5 for now, then comma, force mode 2d.impulse, just to make it happen immediately. Now if we go back into our game and press play, every time we press the spacebar, our player will jump into the air. Let's test it. Okay, now what does broadcast messages do? As you can tell, if we switch the option from send messages to broadcast messages, the on jump syntax and the rest of the on device regained, lost, etc., that all stays the same. And let's press play and see what happens. Let's press play. Now when I hit space, the same thing happens. So what's the difference? Send messages and broadcast messages has the same syntax and it appears to work exactly the same. Well, that's because broadcast messages and send messages are exactly the same. The only difference between these two are that with broadcast messages, you can have this onJump method be on any child game object of the player. So send messages looks for the method only on that certain game object we put the script on. So for the character base here, we have the player controller on the same object as the player input. For send messages, this would work. If we had the player controller in one of these child objects, it would not work. But if we had broadcast messages and we put this player controller on one of the child objects, that would work. So send messages looks for the method only on the specific game object the player input component is attached to, while broadcast messages looks for the method on this object and all of its children. Usually all of my player input will be in one script, so I believe send messages is better. But if you have scripts that the player can input methods on and your children objects as well, then broadcast messages is for you. Besides that small detail, they function exactly the same. Let's take a look at our next behavior. Invoke Unity events. If you have ever used buttons in Unity before, this will be very familiar for you. When we select Invoke Unity events, the onJump syntax gets dropped along with all the other onBlank methods. And in replacement of this, we have this events dropdown. And if we click to open it up, we can see the device lost event, device regained event, and controls changed event, along with our action map dropdown. You can start to notice how all of these are basically the same, but the implementation is starting to get a little different. So let's create on the action map we created, or base combat. And it now opens all of our actions for this specific action map. Right now we only have jump, which is our only action. So that's the only one present. But if we had multiple, they would all be stationed here as well. With the invoke Unity events behavior, what we do is create the method in our script the same way as send messages or broadcast messages. And note that the method can be named anything you want for this. It doesn't have to be onJump or onMove. You don't have to use the on keyword. What we would then do is drag whatever game object our script is on into the correct event slot. Because our script is attached to our player object, we just drag our player object onto the jump event. If we click the sidebar drop-down menu, we now have access to all of the game object's components, but we are looking for the script component that holds the jump method. So we can select the player controller component and click on the method we have created in the player jump. But because we are selecting it in the inspector, we need to make this method public. So let's go back into our code and change the method to public. Now when we select the player controller class, we can choose the jump method. Let's run our game to see if it works. Let's go back into our game, see if it works. That's my dog. Literally. And as you can tell, it does work, but our player goes higher than before. Why does he do that? When we press the key, it triggers 3 times. 1 for the start of the button being pressed, 1 for the button press, and 1 for the end of the button press. So this method is being called 3 times, which explains why our player is going a lot higher. But we only want to call it once. To solve this, we can go back into our code and tell our code cold to only register one of the 3 occurrences of the method. So if you don't already at the top have using Unity Engine.input system, you need to write that in because we need to gather more information about the specific input. And in this method, we can now pass in the input action.callbackContext, and we will just call it context. And all we need to write is if context.perform, then add our jump logic, because our jump gets started, performed, and canceled. So we only want to call it once, so we only need to call one of these different properties. If we go back into Unity, we can see under the events, the callback context as a parameter by default. This is just to gather more information on the action and can be very useful, especially when we implement movement using vector2s. Another drawback I found just now is if you change the method, then you have to reassign it. There, just found that out. There you go. So we can see if we press the space bar, there we go. He doesn't go as high and he only jumps once. Okay, awesome. So for our last behavior, we have invoke C# events, which is identical to invoke Unity events, except we have to manually set everything up. In my opinion, this is the worst behavior because who wants to manually have to set the entire event system up and code when Unity offers a more streamlined version themselves. But I'll still show you how to do this if you just prefer having everything in code, and maybe you are more used to writing events in plain C#. For this, we will need to create an onEnable and onDisable functions to enable every single action we have and to disable it. To start, we will enable and disable the action map, and also enable and disable the jump method we have. And now we just need to call the action to our method, and it is now set up. Now we can call the action and our method is set up. See, in the enable, whenever we're going to jump, we subscribe to this method, and then we also unsubscribe as well for the disable. And you can imagine this can get very tiresome and long, especially when we have a lot of other inputs like movement, fire, dash, slide, driving, etc. You're gonna have to do that for every single different action you want. You're gonna have to subscribe and unsubscribe. And not to mention, you're going to have to do all the logic as well. So it would be a lot easier just to do the logic, and that's it. So this is why I don't like it, but let's go into Unity and see how this works. Again, we have invoke C# events. We press play. If we hit the space bar, null reference exception. Let's see what it is. Line 18. It's not set to a reference. Line 18, player controls dot enabled. Maybe this needs to be in the awake function. Let's see if that works. This just goes to show you how little I use the C# events, just because it's not that great. And there we go, it works. So yeah, if you're gonna use plain C# events, you're gonna have to put it in the awake and not the start method. But yeah, as you can see, it works just the same. All of these are exactly the same. It's just how you're gonna implement them. And there are 4 different ways you could implement them. It's just up to you. So those are the 4 behaviors you could use. Again, all of these accomplish the exact same task, but they all have their own unique way of being implemented. The send messages behavior is the most straightforward. It's also the quickest to set up. It's what I'll be using when I show you how to implement the player movement as well. But you can choose whatever behavior you would like. Broadcast messages works the same, but it just adds another layer. If you're going to use send messages or broadcast messages, I'll just stick with send messages for simplicity. Invoke Unity events is a good choice as well, just because it is visually friendly, and you just have to manually plug in your methods for each of your events. But Unity sets this up for you, so this isn't a bad choice either. And for your last option, which is invoke C# events, this puts all of the work on you. You have to manually set up the entire event system yourself, so for that reason I find it the least practical and often the most time consuming. Overall, I think it's the worst of the bunch. If you're gonna do C# events, just use Unity events. Otherwise, I would use send messages, unless you have children which have input scripts as well. Then broadcast messages is better. I tend to only stick to Unity events and send messages. For the player movement example, I'll be using send messages. For the last example of Unity's new input system, I'll show you how to move your player in the scene. To start, let's open up our action asset, and in our action map, let's hit the plus icon to add a new action. We'll call this move. We'll assign the action type as a value, and then the control type as a vector2. Now when we click the plus icon for this specific action, we can select the add up, down, left, right composite. So let's click that. We will leave the composite type as a 2D vector and the mode as digital normalized in order to avoid any diagonal buggy movement. We can name this WASD for the WASD keys, and now we can assign each of the composite type bindings for each key. For up, it will be W, down, S, left, A, and right, D. Let's hit save asset. And now that our action is created, if we look at the player input component on our player, we can see the onMove text, which means it's time to create this method. Let's open up our player controller script and create a new method, which we have to name onMove. We also have to change this jump method to onJump. So let's do that. So this is going to be a bit different than the button because we need to gather more information on what keys the player is inputting. To gather more information, we can pass the input value into our own method. So we go input value, and we'll call this input value. Now to get the vector2 out of this, we simply say input value dot get, and the type is vector2, so we'll say vector2, and circle braces to finish. Now we can set the rigid body 2D velocity equal to this vector 2 multiplied by a move speed. So let's really quickly create a move speed variable, and I'll make it serializable so we could assign it in the inspector. Okay, so we're going to go back into the game and try this out. Let's hit play. And, alright, I can still jump. Our move speed is 0. I was like, why isn't he moving? So if we up the move speed, I'm just going to say 5 right now. I hit the right arrow key. Also, it's WASD, not the arrow keys. If I hit W, there we go. A moves him left, D moves him right. You can see he's turning a little bit. Just to fix this, we can just go on a rigid body, click on freeze rotation on the Z axis. Now when we move him, there we go. He moves A and then D. We could jump. And yeah, if we wanted to add the arrow keys, it's very easy. This is why the new input system is great. All we would need to do is go here to move. Let's delete this binding. Move. And add another composite, and we could just say arrow keys, and we could just do the same thing. Listen for the up arrow, for the down arrow, listen for the down, for the left, and the right. Okay, now watch how easy this is. We just save the asset, and I don't have to do anything else after I added those keys. We could add whatever keys we want to it. Now, if I use the arrow keys, it doesn't work because the move speed's set to 0. I'm gonna go out of play mode and set this to 5 here. Now, if we try it, if I have the arrow keys, we can move it either way. And here's the little note: whenever you change something while you're in play mode, it's not gonna save. So there you go. But if we move left to right using the arrow keys, it works. We could jump still. And if we use WASD, we can move as well. So that's flexibility you have with this new input system. You could add multiple bindings to one action. And that's going to do it for me. I hope you all enjoyed the tutorial. Leave a like if you did, and let me know what you guys want me to cover next.